We've had a strong magnitude 4.6 earthquake striking the Africa Rift Valley on the fault of Uganda. And we have a lot of large cracks there. This is one of the very dangerous faults of the earth. This is also what gives rise to the area of the Nile, as we can see here. And all rivers we know are fault lines. Recent cracks in Africa are a natural occurrence because of the fact that there's magma under there. It's a rift valley. And there's volcanoes as well. And this is what will be coming of Africa on the eastern side, where we have our rift zone, our fault. Madagascar was once a part of East Africa, and that island there down the 5 o'clock position. And lakes and volcanoes there, of course, are active because of the fact that it's splitting. Let's go to the map to see what happened. Here we are. This is our active area. We've had recent earthquakes as far down as South Africa. And this is another Mid-Atlantic ridge. We have another part of the crack here. The Mid-Atlantic from north to south. Iceland is a mantle plume right on that Mid-Atlantic ridge, and very active with earthquakes that are not small. Okay, now this is what we're looking at today. Our 4.6, and 3 days ago we had a 4.3, and this one here is just older. Oh, no, it was the March 3rd. Okay, I didn't make a video on that, but anyway, you can see that we have a lot of activity here. I wonder how many people reported that. To only 4. Okay, let's go to our map. This is it. Even though the fault line is not placed there by USGS, we see that the earthquakes are telling us where the fault line is. A lot of lakes there, a lot of rivers, a lot of volcanoes, and this thing here as well. And it goes into the Red Sea fault right there, and the Transjordanian fault, which is very, very active. And that's the area of Israel as well. And we've said many times before, the geology of Israel. The Sea of Galilee is actually a crater lake. There it is. Okay, the Sea of Galilee is a great crater lake. And from antiquity, we've had hot spring baths all around there because there's magma under there giving hot water. So that is a crater lake. The Dead Sea and the Red Sea. And following back down, okay, that gives split to the Sinai Peninsula, and that's the Nile River. And you follow it back to the mountains, winding, meandering all the way down to East Africa. And they don't have the fault line showing here, but this is the rift zone. You can see the rivers, the lakes, and volcanoes. That's Lake Victoria. A lot of beautiful lakes here. You can just follow the seismic activity, and that is, of course, where we had our South Africa quake as well, 3.7 on the 3rd of March. So all this is the East Africa rift zone. Madagascar, as we said, was part of East Africa at one time, fitting nicely like a puzzle over here. You can imagine the tectonics and the geologic activity to split that part of the continent off like that. So, going back to what it is. Oh, yeah, no, sorry, about the map. The map, so you can see. Okay, all the way from South Africa, all the way Zimbabwe, Zambia, Tanzania, Lake Victoria. There are a lot of other beautiful lakes, all the way South Sudan, Ethiopia. And there we have the Nile River, and winding its way up to Cairo and the Mediterranean Sea. So this is our activity, and we know that sometimes when we have our activity, you can see that the past 3 days has had this activity here. That's about, what, 2,000 miles distance plus. So when you have an earthquake somewhere on the area in the vicinity, it can give a pressure rise to other earthquakes on that fault line in that region, just like we have here. All these, okay, the 2nd of March, the 28th of February, and this is today. Okay, and we've had, this is only this past week, but we have had earthquakes all along the Mid-Atlantic ridge, and here as well. Now, going back to what it is, the East Africa Rift System, 3,000 kilometers long Cenozoic age continental rift extending from the Afar Triple Junction between the Horn of Africa and the Middle East. The Horn of Africa, as we said, pulling out, in the Middle East, the Horn of Africa and the Middle East, right there, all that. The Afar Triple Junction. So that's, the fault line there. The triple junction between the Horn of Africa and Middle East to western Zimbabwe, segments of active extension occur from the Indian Ocean west to Botswana, Democratic Republic of Congo. It's the only rift system in the world that is active on a continental wide scale, providing geologists with a view of how continental rifts develop over time into oceanic spreading centers like the Mid-Atlantic Ridge, as we said before. Okay, our Earth is growing. It's growing a lot every year, and it's just growing. So this is part of the growing, that's part of the growing, and of course the Pacific part of the growing. This is the Tonga underwater volcanoes. You can see we have a lot of 5 magnitude earthquakes there. This one is very deep. It's in the top of the mantle. So, that's why we have all this activity. Now, the rifting in East Africa is not all coeval. Volcanism and faulting have been an ongoing phenomenon in the continent since 45 million years ago, the Eocene. The rifting began in northern East Africa, led it to the separation of Africa, Nubia, and the Arabian Plates, and the Red Sea and the Gulf of Aden. Okay, the Nubian Plate, Africa, Gulf of Aden, right here. As you can see, that was also part of Africa. And again, that split off. That's cracked as well. A lot of activity with Africa. So the Paleogene mantle superplume beneath East Africa, causing extension within the Nubia Plate, as well as the first order topographic high known as the African superswell, which now includes most of the eastern and southern segments of the Nubian Plate. Widespread volcanism erupted into much of the rising plateau in Ethiopia 45 to 29 million years ago. Okay, Ethiopia around here. So you can see what's that. Volcanism there as well, volcanoes. Now, widespread volcanism, we said, with chains of volcanoes forming along the rift, separating Africa and Arabia. Okay, volcanoes there. Volcanoes here, volcanoes here, volcanoes around here. And if we go to the, why not? Let's go in here, see if we can get some lava flows. I think these were the lava flows right there. And we also have a lot of oil and gas and tar. You just scrape the top. Oh, here's one. Okay. You just scrape the top and you have it. That looks pretty good. The image is not very good, but anyway. Okay. Okay, there you go. That's one there, right there. Isn't that something? Okay. That's beautiful. Okay, so you can understand there's a lot there. Now, today's extension and magnetism are localized in distinct eastern, western, southwestern branches, marking the edge of 2 or more microplates between the subparallel zones of extension in East Africa. The border of the microplates known as Victoria and Rovuma, with the Nubian Plate to the west and Somalia Plate to the east, now representing the most seismic active zones on the continent where normal faulting earthquakes occur every month on a monthly basis. They're also the site of volcano-tectonic earthquakes. Along the rift, models of sparse GPS data and earthquake slip vectors predict average spreading rate of 1 to 4 millimeters a year, increasing from north to south in the western branch and increasing from south to north in the east. Seismicity in East Africa Rift is widespread, but displays a distinct pattern. Seismicity characterized by shallow, less than 40 kilometers depth normal fault, earthquakes rupturing as a direct result of extension of the crust and volcanotectonic earthquakes. The majority of events occur in the 10 to 15 kilometer depth range, as we have this one. The pattern is widespread throughout years, and the relationship between depth of earthquake, the deformation of continental lithosphere, and magmatic processes in many segments of the rift. The three limbs of the FR triple junction zone experience major earthquakes, as well as frequent volcanic eruptions and dike intrusions. The magnitude of earthquakes during volcanotectonic events is usually less than 6 magnitude, but large volumes of magma accommodating plate opening may occur during these intense small magnitude swarms. The largest earthquake recorded in this area occurred in a swarm along a section of the evolving Arabia-Nubia plate in August 1989. Studies of the earthquake swarm show the events occurred as a result of slip on conjugate normal faults bounding the narrow Dobie Graben, and the swarm, made up of 25 magnitude 4.3 earthquakes, occurred over 2 days, August 20th, 1989. The events were shallower than 15 kilometers as a result of thin crust beneath the triple junction compared to the surrounding continental crust. So again, we're talking about the East Branch is a discontinuous system of rifts, most of which have experienced magmatism since their onset. From north to south, these are the Ethiopian Rift, the Kenya Rift, the Northern Tanzania Divergence, the Davy Ridge, the Kenya Rift experiencing major 6.9 earthquakes in 1928, but has witnessed only small magnitude swarms since then, as in the Afar Ethiopian Rift segment, where magma supply appears to be abundant. Dike intrusions here accommodate extension strain at lower stress levels than are required to cause slip along large fault systems bounding in the rift, generally resulting in relatively smaller earthquakes. Seismicity near the northern Tanzania divergence marks the diffuse volcanically active Victoria Somalia plate boundary, and consistent with widespread magmatism. In this rift sector, earthquake magnitudes are generally less than magnitude 6 as a result from normal faulting. Okay, so this is normal activity. Let's go back out. Okay. All this desert has a lot of volcanoes. It's just a matter of luck when they're going to. It's a huge desert. Okay, the Nubia plate. And this is our activity right here. And in the past week, we've had earthquakes all along this fault. Please leave your comments, and thank you for your support. Please support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support, and that you find all my content so interesting. You'll find the Patreon account details in the description box below.